early morning. My name is Carina, haupt, and today I want to give a talk about the semantic web, raising of the dead. So first I want to give you a short motivation why I'm giving this talk, because every time when I'm somewhere people ask me what I do for a living and I'm saying I'm working with semantic web, I get like, oh, you for saying I'm sorry for you. And this really sucks. In my opinion, the semantic web isn't bad. But that's my opinion. I don't want to talk to you like I would know which is right or wrong. But I want to give you the knowledge about the technology behind it to make your own opinion if the semantic web is bad or not, and if we could use it for something. So that's what I want to talk about today. The first thing I did was a little background research, meaning I just Googled semantic web is that versus semantic web is not. And as you can see, there are like 84,000 hits for it's not that versus 6,320,000 hits for it's that. To be honest, like for every statistic, it's kind of trick, because if you just add a the to the beginning, you get like 9 hits for it's not that and like 1,000 hits that. So of course, but as a good researcher, I'm faking my statistics the way, or I'm presenting it the way I like. So semantic web is not that. Okay. Most people who say semantic web is that and oh, what you're doing there have no clue what it's really about. So what's the goal about semantic web? The idea is to solve semantic and context sensitive problems. Meaning, perhaps a lot of people of you know the TV show Big Bang Theory. So in one of the first episodes, there's a problem that they want to go to the cinema. And of course it has to be a state-of-the-art cinema. It's a digital projector, and because Sheldon, who we all know, is a little special, there must be a special ICs machine, and also they have to sell special sweets called red wines. Next thing is they want to go to dinner before and have of course this all has to match in time so that they can have dinner and then go to the movie and be in time to see all the advertisements because they're fan of it. So what they would have to do is visit a lot of pages in the web to collect the information they need. So they need a web page for finding interesting and good restaurants. They have to look in which movies the movies that they want to watch is running and at which times. And then they have to go to the movies web pages to find out if they sell the sweets they like. And if they have a digital projector. And last, they have to find out if all of this matches in time with the time when the movie starts and where the dinner is and how long they will take them to go from one place to the next. So, of course, this means a lot of work. So in the semantic web, the idea is all this information are already in the web. So we just have to connect them. So what you see here is the linked data cloud. The linked data cloud is an amount of different data sets which are connected to each other. That's the idea about the semantic web. With all the data sets we have, you can connect and link to each other. In the center is a bigger point, it's a DBpedia, which is a RDF or semantic web representation of the complete Wikipedia, which is generated quite often. So of course a lot of stuff links to there. But we have different areas from life science and so on. So for our example, we just say the pages I mentioned before are part of this linked data cloud. Then we could get real results like this. So we could get a suggestion which restaurant to go and to which movie to go and at which time we have to be there, and this movie would fit all our needs we asked for. But of course such a result is totally unrealistic. Hey, why do people think the semantic web is such a big thing and it could really work and do stuff like that? Because the technology is really capable of doing this, which is quite nice. And that's why I want to represent you how this technology behind the semantic web looks like. So in general, it's a world of triples. So everything, every fact, every piece of information is stored as a triple, meaning it's a subject, a predicate, and an object. So in my example, because we are talking about the undead here, we have undead A, who is, for example, the mother of undead B. This is one statement, this is one triple. And we could easily extend this example by giving, for example, connecting names to them, because as long as it's just such a round bubble, it's an entity, so it's describing something. But until now, we just know that it's one specific entity. We know nothing about it. So we add, for example, names. And in this, more quadratic symbols, their literals always stored in. It's a common representation of the semantic web. Literals means it's strings, values, so something which is really a value in programming. It would be, it's the content of the variable or generic data type. And we could extend this. So if you know that Annie B has a sister and that's C, you just can connect this. And like this, you get, if you add more and more information, you just get a complete graph. So we're more or less a graph-based database or something like this. So you can store, of course, all the information and just connect them to each other. To identify something really specific, like one special entity, and decide undate A, and differentiate between undate A and undate B, we have to use something to identify them. So there's URIs used. So I think most of you know them. So they can link to something on the web, but they don't have to. But they look like normal URLs most of the time. So, and this is how our example, a small version of a small part of it, would look like in RDF. So RDF is a format, it's the idea about triplets. It's not how it's really presented in a text file, but this is one example for how it could look like. So you have a URI for undate A, you have a URI for the predicate, and you have a URI for undate B. And this you have for every, so always two nodes and edge form one triple and form one line in this representation. Of course, there are also different ones. So a little shorter, which is easier to read because you make, for the namespaces, you have just like shorts, you define them on top and then can reuse the short forms. Or there's also an XML-based representation for all the people who love to parse XML. And the nicest thing that even asking on this data queries is more or less the same like tracking data. So if we have our graph and we want to know, give me all children from an entity which has the name March, it's quite easy. We use Sparkle. Sparkle is a combination from SQL, Prolog, so logical programming language, and regular expressions. And we see it below. In the first row, we see question mark child, and obviously with the question mark is a variable, so it's just a placeholder. So we search for something which has a mother, which is another entity. And about this entity, in the next line, we know that it has a label. And when we then jump one, we go to the filter, we say, okay, this label, the mother name, has to match March, and it's case insensitive. So, and the last thing we get is we say, from the child we want to have the label, because of course we want to see the names of the children and not just the entity, which is just a long UI. We want to have the real name representing it too, as a result. So you see, you can really easily navigate through graphs, even through really, really long graphs, by reusing the variables and there is creating a query. And then there's something which is called reasoning, which is something which is, I think, not common in the relational recursive work. So we have our information, which I presented. That's the data we generated and we entered into our database. But because of the rules we know, like which is a predicate is mother of, we know stuff. So if we know something is the mother of something, we know it's from the type mother. And because of the type mother, we know it's also a parent. And we know it's female. And the last thing is, it's a person. The nice thing about the semantic web is that all the predicates we have are stored in ontologies. I will come later to this to explain in more detail, but the idea is that you can have hierarchies and you store this with once. And because of this, you have this knowledge in the background. And with reasoning, you just can create new knowledge about information you gave. So it's just combined. For humans, it's totally clear that if somebody is a mother for something, it's a person and it's a mother and it's a parent. But of course, the computer doesn't know about this. And just based on the some predicates we have here, we can make a lot of reasoning. So for Bart, we know it's a child because it had a mother, so it's definitely a child. And our Gordon is the person. For our undate C, which is Lisa, We know it's a daughter because it's on the right side of the has daughter predicate. And we also know that it's female and it's a child, because of course the daughter relation says it's a child. And it's a person again. And also for Homer we know that it's at least a parent and a person. Some of you would perhaps ask, why don't we know that Homer is a father and he's male? Because just because somebody has a daughter doesn't make him a male. Of course it could be a woman too. Of course you could say, okay, we already have a woman here. But on the other hand, it could be also two women. It really depends on how you define your predicates. So what do you define a family or even relations like sister? Is it really a sister? Could it be a stepsister or something like this? So that's kind of a problem I will mention later. But not only from the types and everything you can get knowledge. You also have like further additional predicates which you can get out of it. Because if somebody is a daughter of somebody, of course the other right is that he has a parent. The other one is a parent. And I just wrote down here some of the reasoning you kind of have, because they're like, the first thing is you can always change the direction normally for a lot of these predicates, and you also have their hierarchy. So if somebody is the daughter of, he's also the child of, and so on and so on, and a blood relative or something. The nice thing about reasoning is that it allows us to answer, of course, much more questions, because with our original data, if I asked like, I could ask questions like, give me all daughters, and I would get Lisa, but I'm more or less lost there. But now I can ask like, give me all children, and I would get Lisa and Bart. Give me all persons, I would get all the formulas or something. And so on and so on. I'm now much more capable to ask questions about specific categories of people, but also using different predicates. I just entered some, but now I'm possible to use a lot of different ones, which is especially important if I merge data, but also that's something I'll come later to. So, again, why reasoning works. You write the rules once, but you can use it for all your data. So normally you have once defined what the rules are. For families, that's of course clear for everybody of us, but you can imagine this in chemistry, for biology, and everywhere you can imagine something. And you create knowledge for every entity which you have out of this, so new knowledge. As I already mentioned, it enables you to answer more questions, which is especially important because also the questions don't have to match exactly to your data, to your original data, because now it's much more general. And with the most data stores you use for RDF, you can switch it on and off if you like. So that's something really nice if you have rules where you say, okay, like I always go with the classic definition of family, which is like what Facebook's doing. Because they say, if I give a suggestion, somebody's like, in our example with Homer, that Homer would be the father then. I'm right most of the times. So giving the suggestion is fine for me. On the other hand, if you have another use case, like you want to really create your family tree or something, of course such a suggestion can't go for you. You really want to have the real information, so you would just, don't use or append the rules. So now I talked a lot about one data set, but what was the web thing? I mean, yeah, we used URI, but in the end, that's not really the web part. So as you remember, we said we want to link data sets. That's what the semantic web is about. But how is this working? So linking data in RDF is really, really simple, because as long as you use the same URI, you map your data. If you have the same predicate, you have a mapping, because it's the same relation which you express. So we have one example here for this. So on the left side you see a part of the example I brought up with The Simpsons, and on the right side you see like a data set from a movie database where we know that under B, which is here Bart, and under C, which is Lisa, are both actors of The Simpsons. So now it's completely different data set, but when we use the same URI, it will look like this parse without having anything to do, because same URI means same entity. So it's directly connected automatically without having to do something. So we can connect data sets quite easily. To query this, which is one interesting part, of course, is you use, again, Sparky queries, which have just one specific line, and that's where you switch to the other data set. You just have to say that you switch to a service like movie database or something I just made up. And they just have to provide a Sparky import or an RDF file. And suddenly you can use the data and just create it once. So that's something which is really nice. The next big part, which is doing this web thing in the semantic web, is that you use vocabularies and ontologies. I already mentioned that you store all the knowledge, like what you know, the rules about families and how they are hierarchical ordered and everything, you store in ontologies, so it's really knowledge. And there's three general types. It's RDF, RDFS, and O. That's the most generic vocabularies or ontologies you can have, and which are like the basis of the RDF, or the semantic web. Because you use them to also describe ontologies. So meaning, for example, for, which is friend of a friend, which is ontology used for social media. So if you want to describe it, you use RDFS and all again. And there's also SCOS, which is a broadly used vocabulary which is for mapping and linking data to each other. So let's look how such an ontology looks when you go to the web. So of course this representation is not really nice for us. It's the RDF, it's an RDF XML representation in O for friend of a friend. And as you see, it's RDF all the way down. So RDF is described in RDF. Of course, there's also a version for humans to look at because nobody wants to deal with these files. So there's a nice version where you see which classes exist, like person or something, and also all the predicates which are existing. And you can click on it and you get a real nice description with a description text and a definition which is allowed to be on the left side and on the right side. For example, for is mother, both entities on the side have to be persons of the type. Because, so you can really make sure that everybody is using this predicate in a way you're supposed to. And that's a nice thing, because if people reuse the same predicates, we have a mapping, or if they use the same entities. But of course, somebody has to define somewhere what is understood under this entity, or this class, or this predicate. Because of course, everybody would interpret it in a different way. So let's come to the problems we saw already. The first problem is everybody in the web would have to use the same URI for the same entities, classes, and predicates. That's definitely not happening. Even if they are stored in the web and they are there, it's really hard to find them. And also a lot of people just don't make the effort and just create something new. Also, there exist a lot of them who already overlap. So it's hard to decide which one is the best for you. And it always depends a little bit on how your data exactly looks like. So that's kind of a problem. And the much more general problem, everybody would have to use RDF at all. So this would mean that every web page I mentioned in the beginning would have to represent their page as RDF. And of course, this is definitely not happening. And the last problem is, when the semantic web came up, we didn't have the tools to reuse it really. So it was really hard to do reasoning. You didn't have nice tools so that you could give it to people and say, okay, RDF making and creation is totally easy. It was all had to be done by hand. And this is the reason why the semantic web died. But just for big studies, because it might be hard to get everybody to do something like using the same predicates or using RDF at all. But for a small subset of people where you can say you have a common use case and you want to access your data each other, this could be a nice thing, because something I didn't mention until now is that the advantage, if you think about it, when you have a change in the data, because it's in the web and it's linked to each other, you just have to change your queries. When you want to combine a lot of data sets in a relational databases, or using the relational databases, You normally have a data warehouse, meaning you have to be capable to handle updates or changes in the data to get the updates into your store. You have to update the mappings between the files, and you have to update the queries. But because the triple stores are just available on the web, you just can give them for free open. People just can just have to update their queries. So changes are not free, but they are cheap. So now there comes a little bit of self-advertisement, because I'm working in the Open Facts project, and that's why I started to work with the semantic web at all. And it's what I said, it's a small subset of people or of common interest, which is here the pharmacological field. So it's about genes, diseases, and the mapping between these. And they tried to solve problem number one, which was to use the same predicates or have the same URIs for predicates and classes, and entities and classes. And for this, they just provide two services, which is the instant mapping service and the entity resolution service. The first thing means you give them a URI, and you get back a bunch of other URIs representing the same entity. The nice thing is in chemistry, this works quite well, because of course there are like hundreds of different people who talk about aspirin or something, and they all have it in their databases, and they all have their URIs for that, but they mean exactly the same thing. So you just have, we present one service, where you just send your URI and you get back all the alternatives, and can work with that. The next thing is the entity resolution service, which is going one step further, which is saying, if you just have the word aspirin and you want to get a URI which already existed, you ask it. So you just give the name, say, okay, I mean aspirin is a medicament or something, or I don't know, and you will get back the URI. So this helps to solve problem number one. Problem number two, which was everybody has to use RDF, is solved because for a lot of databases, we are just creating the RDF script because we need this data now and we're allowed to use it. So we are creating the scripts and say, okay, here you have scripts, here you have a how-to, and it's really easy. And please always, if you create a new version of your database or make an update, just please run the script. And you will just have RDF there for us. Because there's a lot of community projects which we have there, so community database, which are really created and looked after by just the crowd. So the nice thing is that they're really happy if you can say, okay, we make your data more available to people and everybody can access it easily. And you can be part of our big project, Open Facts. But we're not the only one who tried to do something like this and bring semantic web back. There's also, in the field of biology or life science, the Bio2RDF project, which is really dealing especially with everything in the field of biology. The DBP here, which is, as I mentioned before, RDF version of the Wikipedia. Wikidata, which is, we're one of the workers of Wikidata View, so, which is one of the projects who's also trying to really make Wikipedia better or more semantic. And also Google starts to use it again. So they just bought a big data set, we could say, called Freebase, so another company which is doing RDF, and they want to change their search engine, which will change like 70 to 80% of the search results, because they want to add semantics. And if somebody like Google started, we are really close to everybody starts using. So I think we're on a way that the semantic web raises again. Perhaps won't be that. How far we will get, we will see. And there is, I want to finish my talk. And hope you have fun. And if you have any questions, I'm happy to answer them. And I hope you got a little impression how the technology behind the semantic web works to get your own idea if this is a good thing or not. Thank you.
Frage unten.
Okay, there's somebody having a question, so it makes sense that we work on the microphone.
Just repeat the question when you answer it.
Okay.
So, I'm wondering why you mean that it's such a big problem that people use different URIs for the same things. You can interlink them with the same as predicate, and I don't think it's such a big problem. It's not really convenient, but the problem is not so big.
There are two. He asked why it's a problem, or why he said it's a problem to link data, so that people, or why it's a problem that people use different URIs for the same entities, and that there's the same as attribute, and you could easily link with it. You're right, there's the same as attribute, but the creation of this linking is hard, because somebody has to do it manually, and he has to be sure that it's really the same entity which is meant. So, and because it's so much data alone in chemistry, we have like millions and millions of different entities which are just representing different chemicals or something, that it's really hard to say, is it really the same thing? There are automatic approaches to do this, which is fine for some use cases. But in the end, can you make sure that somebody who's called John Doe on Facebook is the same one, John Doe, on Google+? You can look, of course, at attributes and be quite sure, but 100% sure can just the owner of these two profiles be. So he would be the one who has to make the mapping. And it really depends on the use case. So if you want to be vague and say, okay, I just want to get an idea, it's totally fine to use automatic generated mappings. But if you want to be really, really precise and give really specific answers back, which you perhaps don't have if you Google something or so, but which you need if you want to put the data into a text like in Wikipedia, or if you want to give ideas about genes and diseases or something, like what I'm working with, it's quite hard to make this, like, to prove that it's really the right same as relation. So you can do this, but it's depending on your use case if it's easy or if it's really, really hard. Some other questions? Yes.
Hi.
Hey.
Oh, microphone. It's working. So, assuming I'd be the owner of a movie theater and I wanted to add semantic data to my website, and personally I'm not that comfortable working with RDF or XML at all. Are there any tools available?
Sure, there are different tools. So one which I just quite new, you could say, and it's really easy, is from Google, which is called Google Refine. You can present your data like in a spreadsheet or a tab separated file, and quite easily click yourself through to create RDF out of it. And the nice thing is you just have to give like the namespace, which is commonly used, like scars or for friend FOAF, and he will load all the predicates and everything which will exist, and you can just click yourself through, and in the end you will get valid and nice RDF. So that's just one tool, but there are a lot of tools to help you doing this, depending on the basis of your data. There's also even like tools which you can plug onto your relational database, and we will then, you give it like a model how your data should look like, so like this graph thing, and he will present your data, or will make it part of the semantic web by giving it access or by using Sparkle. So even if you have a relational database, you can do this quite easily.
Doesn't this pose a danger to anonymity on the web? So for example, if there's a semantic relationship between IP addresses used on different websites, like a database stream. And then I browse a website where I want to stay anonymous, where my opinion should not be attributed to my person. And then I use the same computer to log into Facebook, and then suddenly there's somewhere some kind of linkage between these two. Wouldn't that be a danger for me or for everybody using the internet?
I mean, of course, the idea about semantic web is combining data. And of course, this can be a problem, sure. The thing is that web pages should make sure this means that those web pages gives us information out freely and makes it open available. So, of course, the semantic web would make it easier to connect this information. And that's perhaps something which is not a good idea for data or for personal data, and that's something we don't want. But in general, I think the main problem is that this data is publicly available, and that people also connected it somehow to the link to the semantic web or somewhere. But of course, like every technology, there can be ways where it's used in a way which we really don't like. Yeah, could happen.
I think one problem with semantic web technologies is that it's mainly inside an academic bubble. So if you are a hacker and you don't have that much of an artsy-fartsy computer science academic background, then this might sound like a lot of made-up words to describe made-up concepts. But I just wanted to point that since we're at a CCC conference, most of you probably are already familiar with the uses of the semantic web inside the CCC, because it's more widespread than you would think. For instance, there's a directory of all the hackerspaces in the world online, and that is done with Semantic Media Wiki. So once you log in there and you fill in the coordinates and you fill in on your wiki site what hackerspace you're a member of, it will all become part of the semantic database that is behind hackerspaces.org. And of course, behind the scenes, it's all RDF and Sparkle and what have you, and you can do nice things like having a world map of all the hackerspaces in the world, stuff like that. Also, if some of you have ever been to one of the CCC camps, the camp wiki is usually done with Semantic Media Wiki as well, so you can do nice queries about what villages, etc. So it's if the academic side of semantic web scares you a bit, it's really not that scary. It's just what I wanted to point out.
Thank you. I think that was a really nice initiative. Thank you.
I have another question. Are you familiar with microformats and microdata?
A little, but there's a new concept which is based on that. It's called nanopublications, which of course, again, is a research or more scientific background. But the idea about nanopublications for everybody else is to make, it's the idea, the name says it, you make the most smallest publication you can imagine. So yeah, it could be like one triple, where you add provenance. So say, who said that this triple is true? For example, for say mass mappings, that's important that you say it was this person who said it. And you also add perhaps context under which it's valid. So for example, that's something which you have a lot in of course in experiments, and I'm always coming back to this chemical background because I know all the examples. That, for example, two entities just mapped if it's a specific temperature or something, or that they then interact or something. So you can have a statement that chemical A interacts with chemical B, but just under the context it is plus 25 degrees or something. And you have the provenance about that this one guy in the lab sitting there, he said that, he found it out. Is this what you were targeting, or?
I think especially microdata, which is a new standard, is the
I think what you wanted to talk about is earlier A.
The microdata standard is a part of HTML5 of the working group, and it's a bit of pushing semantic web ideas into HTML, so that you so that web developers don't have to write RDF, but can express semantic web ideas inside their web pages. And there are tools that can transform back any web page that has microdata in it into RDF, if you want to put it into that context.
Yeah, so I've heard from that, but didn't use it till now, or tried to figure out something with it. But that's definitely a concept about, yeah, making the use of RDF more widespread. So.
Vortrags kommt. Hi, a second.
One more question?
Ja, wir haben kurz nochmal.
So my impression is that the incentive to make semantic web pages on a website is just about the same as the incentive to not make tag soup on your web pages, and that's a very distant objective, a very positive point, having clean and semantic web pages. But for the web developer, for the average Joe Doe making this web page, the question will inevitably be, what is in it for me? Many people can really understand why it's nice to have clean code and tag soup. But then when you have to run a business and you have other priorities, it doesn't really matter what the quality is behind that. And my feeling is that there's a very large risk that we get the same, we get a form of reasoning that says that, okay, Google is going to figure it out. Google is going to take the content of my webpage and figure out what the date was, and that this is an author, that this is a picture, and so on. And then that instead of a semantic web, what we get is a semantic Google search engine or a semantic Google database. And it's, to me, a very large difference. So maybe you have thoughts about this.
So about, I really share your opinion there, because Google has created a big database of entities. And I don't know what they exactly plan to do, because they didn't publish everything. But my suggestion is that they will make something like they try to figure out what. For one example is always I don't know, the words in English are the same, but the animal jaguar. And so that's for Google the main problem. You have jaguar. Do you mean the car, or do you mean the animal? So of course, one solution is for you as a normal web developer. That's why I say. It won't happen that everybody will use RDF for their data, because most people say, why should it? But in the end, if Google figures this out for you, it makes it easier. But if then people stop, so who really run commercial software, web pages, say, I really want to make sure that they figure out the right thing, and I can help them by providing some information, people will perhaps start. So that's the start. On the other hand, that's why I said it's something where I think which is really for specific part or sub-areas of knowledge where this is important, because especially in chemistry, Google completely fails. It's really, really hard to distinguish there between different entities. So the protein of something, the gene of something, so they can have a lot of the same attribute. That's why nearly no researcher for something like this would use Google, because it's much too unprecise. So you will never get really the specific information you need. That's why there on the app with all this specific saying this is the URI describing this entity, there it totally makes sense. But if you just search for, I don't know, all those generics like give me some videos about a famous music group or something, Google will figure out that you mean it, what you mean, and you will get enough results who are fitting you well. So yeah, it really depends all on the use case, and I'm not sure RDF will work for the whole web at all, like in the best way how it could be working. So okay, there's one more question in the back.
I have an addition to this question, another question.
In addition to the answer to this question, I don't think that web developer or people who have a website will have to handle RDF in the future. At the beginning of the World Wide Web, you had to know HTML to have a website. This is not true today. You can open a blog, install WordPress, or use an existing service to have your own blog or website, and the same will come true to RDF. For example, any click on the like button on Facebook is in fact an RDF triple. It says subject, you, likes as predicate, and you like something. This is the object. It's in fact the logic of an RDF triple. It's not RDF XML, but I think in future we can generate RDF by the services we use and publish it on the fly while using the web.
Sure, I mean that's what's in parts already happening for with the micro formats or something. If you enter somewhere in your blog that you're the author and it was written at this date and all this code and this is the title of something, in the back it can be automatically created RDF because of the file where you enter it. It's clear that this is like the predicate. So it's not you really have to do it. That's why I said we didn't have the tools back then, but now we have tools where we can say, okay, we just create like on the fly how we create the HTML website. We also create the RDF and edit or use microarrays, which is another similar approach.
Yeah, I just want to add to this that for mostly any popular content management systems, there are already extensions to expose the data in RDF formulations. So
yes.
that it is getting really easy. So there's no real reason for not doing it. So.
The only problem is giving RDF is nice if you have RDF crawler somewhere who then deal with this data. But the next step is to really link it. Because that is why it's important to use always the same predicate for author. And already up to now, they're like, I could just mention 3, which I know just because like after like 2 months looking into something, you will have like 3 or 4 different versions which are really brightly used for describing the author. Of course, you can have mappings between predicates too, but that's all the problems. It's getting a little fuzzy, and it's getting easier and easier to use. But really connecting it to have a really nice linked semantic web still is the task which is ahead of us. And perhaps Google will help us with this. But we will see. They're just start now.
But the problem is we also need Google because I don't see how semantic web will help if 5 different people blog on their site, and if I want to ask what weather it was yesterday, so I have to know that these 5 people blogged about it, and then I have to ask every site for the RDF. So with the semantic web, we also need a big data storage, or is there any idea how an interlink between these weblogs can be made without a big Google?
The thing is, you always need, if you want to search over several data sets, you need any kind of search engine. So one example, of course, is like a Google-like semantic search, where you just search for general things. But it could also be that you have much more specific questions, like just the weather, so something, again, chemical background, so you search for something specific disease. You can perhaps say, they are search engines, it's what we also provide, where you can say, I just want to search for this and this and this database, for example, and interconnect them. Because I don't want to, for example, especially something like blogs, I don't want to hear what people write in blogs about the weather. I want to know what real weather websites tell me about the weather. So that's why you need provenance for RDF. But in the end, you will always, if you don't want to have the use case, if you want to present something like, coming back to Wikipedia, where you represent article which you just enrich with, or just, but which you enrich with information you have out of RDF. That's one possibility. But if you want to search and get really specific answers, you will always have to do a search engine. I mean, that's the same for the rest of the world. think we're done, or is everybody else having a question? I don't know how late it is, I'm not sure, but we have to finish anyway.